Perfect. Let's just wait another 30 seconds. As I said, make sure everyone has a chance to join, and then we'll get just right into it. All right, let's get started. So let's start with a short introduction. As usual, feel free to ask questions in the chat during the training. If you have a question that I feel is important to discuss with the relevant information on screen at that moment, I might take a break from the presentation to just discuss it directly. If not, there will be a Q&A at the end of the talk. We'll start with the goals. The use case that essentially was the starting point of this entire idea is, let's say, as a developer in charge of a web application, that you need to collect data. You have large data structures. The data that you want to collect require the end user to fill many inputs. Some of those inputs will be text, some of those inputs will be numbers. There may be more complex arrays of controls. For example, if you have something that need to be represented as several inputs taken as a whole, this type of situation. If you do have a small amount of forms to create, it makes sense to just go into ZUL file, start typing ZUL code, and create those forms manually. But if you have a data structure that is large enough, at some point you will want to look at the shape of the data, what the data that you expect to retrieve looks like, and you will want to create a system that automatically generate those forms for you. So what's the design philosophy here? First, we want to separate the design of the web form, which is to say the abstract relations of data that underline the form, and the presentation layer, which can be ZK, but could be something else. We want to output those forms either as a ZUL file. The interesting part of a ZUL file is that you can then modify it. You could have a basic shape of the form generated by the system that you then augment by doing manual adjustments to it, or you can just use it as is already in an existing system. You could also create those form object directly as component in an existing page. We also want to be able to make changes to the data schema, the input that we will provide to that system, and we will want the form generated by that data to reflect those changes. So if a type of data changes from a string to an integer, we will want to change the form object representing that data, for example, from a text box to an inbox. Or maybe we decide to give a different default value to a field. We want the generated form to reflect that as well. All right. Now that we've outlined the goals, how do we do that? The first step is to abstract the form. So what is a web form? Pure data describing a user experience. In this case, the user experience that we want to describe is simply a user going into a page, being presented with a set of form functionalities, which is to say the building blocks of a form, with a number of controls of elements applied to them to make them usable by the end user. We want them to fill data into that form and then save that data to somewhere. We don't necessarily care at this point where the data is being saved, just that we have a way to retrieve that data and do something with it. Okay, so a form row is a functionality. As I just alluded to, what is a form? It's a collection of items. It's a short text for a username, for example. It's a long text for a note block. It's an integer for an age. It could be more complicated functionalities. For example, if you want to input a credit card number, a credit card number could be a text field with controls. It could be 4 text fields which are linked with each other that provide a more in-depth control over the 4 times 4 digits. Maybe you want a drop-down, in which case you will have to describe it with more information. But if we take for the purpose of this proof of concept, essentially, the most basic building blocks of a functionality are an identifier, because we need to identify which data we're talking about. So it could be a username, it could be the user password, it could be the employee number, one data point. We want to define its type, which is to say the shape of that data. Is that data a short text? Is that data a long text? Is it a date? Is it only a label that we want to display, but we don't want the user to interact with, etc., etc. For this training, I've defined some basic controls, but of course, this scheme is meant to be extendable. And the proof of concept that I'm going to display today is meant to be easy to extend, easy to add new data structure as input, and easy to add new templates as outputs. All right. For all of the information I'm going to talk about today, when you see a sample on GitHub, you will be able to go to this link to find how it is implemented in the project. And let's, speaking of it, go and have a look. The representation of a form object in this project is a form builder item. It has the 3 properties that I mentioned just a moment ago. It can be extended or it can be modified if you want to add any additional field. As I said, for now, we're trying to just show the general principle and how it can be implemented. All right, let's get back to actually talking about code. First step will be to build that abstract model. To build a ZK component from that abstract model. You will need the PowerPoint. PowerPoint is going to be made available at the end of the training. That's correct. As well as the recording of the training and a direct link to the project as well. All right. What do we want to build our form model as? We can build it as ZUL code or we can build it as Java code. As I mentioned a moment ago, again, if we build it for ZUL, what we will generate is ZUL text, which can be used directly to create the content of that ZUL text with executions create components directly, or can be stored into a file to be used or to be modified by a developer. If we process it for Java components, we will skip the step of creating a ZUL output. We'll just render directly components based on the definition provided by the model. The main idea is this. We have data with a shape. In this case, you can see objects that are defined by a name, a type, and a value. And we want to generate a form that represent that data with the proper type of controls. So in this case, our first object here is a short text. So we want to represent it by a text box or a similar short scale text input component. It has a name. That's the name we're going to use to retrieve a value from that object. And it has a default value. In addition, because a form may have separate sections, we want to represent it in a sort of a tree where each item may have children or dependent objects. So in this case, I've decided to have a second input of type integer, so represented by an int box, integer box, and with a default value of 12. How do we go from data to output? We add a processor to process that data into the output. Template or renderer. The template approach, as I mentioned earlier, creates ZUL. We take template strings and we fill in content based on the data. We use a set of templates. This is extensible by adding more templates for more use cases. So in the default case, for this training, I've provided 3 templates, which is a short text, a long text, and an integer. But for example, we may want a hidden text for a password, or we may want a label only to be able to output a name in the field of the form, but without providing an input to the end user. We can also consider the renderer-based approach where we use Java directly to render those items. Let's take a look at what that would look like. There we go. The default template are here. Default template are very simple strings. We simply say, if I want to show an item of type short text, I will simply create a ZK label with a value provided by the node. I will also create a text box with a value also provided by the node and an ID which I can query later to retrieve this data. Same for a long text. So in this case, a long text is also a text box, but it is multi-line and it has a height by default. And if I want an integer-based template, I'll replace it with an inbox. Okay. For the renderer approach, if you've ever used a renderer in ZK, this is the same ID. You provide a renderer class. Here I have a demo renderer, which takes a form object as the input. And depending on the type of that object, will create ZK component dynamically and return those components to whichever process has requested them. All right. Now that we've established all of this, let's get into some specific samples. Sorry. One last step before we get to that. I should read my slide. One last step is we don't want to simply generate a flat form that doesn't do anything. We want to have some basic functionalities. I mentioned we want to be able to save that form. Once the user has provided data into the inputs, we want to be able to retrieve that data. So a simple solution for that is to provide each form generated by our system with a basic composer. And that basic composer, very simply, is able to read the different type of objects that exist in the form, find whether or not they have an ID using ZK get fellows, which will return to us all of the components with an ID inside of the same ID space. And then for each of those components, retrieve their data based on the type of control, which they're represented as. All right. Now, let's see how we build that. Let's get into some actual world example. Could you use MVVM binding as well? You could create a basic view model to put in the templates instead of a composer. However, now that would work because you can bind on arbitrary fields. You just have, when you create your view model, to pass in the form model. And then to query that individually. That's a good question. It's something I might just add into the demo project after the talk because it's not in the scope of the current talk. But I think it's an interesting way to approach it, and I don't see any reason why it wouldn't work. So I'll come back to you once I have had a little time after the talk to just put it in. Okay, so First, building the model. As I mentioned, the core ID is to base the generation of the form on that model. The most basic way to do this is to just build the model in Java. So let's take a look to the first composer. In this case, we are creating a form model. The form model, as I mentioned, is essentially a tree. So as a convenience, it is based on a ZK tree model. You do not need to have experience with ZK tree model to use this specific sample. The only thing you have to know is it's based on nodes which themselves have children. And by adding a children node to children node to children node, we create that tree recursively. So let's say we want to create a simple form with 6 input, with 3 of those input being children of the first input. The only thing we need to do is to create a form builder model with a root component. And then we can start adding form items to the model by adding them as children of the root component. And for the one that depends on one of the existing item, we simply add them as children of the existing item. So how does that look? If we go to the browser tab, I'm going to put those side by side so that you can get a good view of both of them. We create an input one, which is a short text with the default value foo. As children of this, is that, yeah. As children of the node 2. As children of the second node, we create an integer, another integer, and a long text. We put those as the children of the second node we create. So a short text named input2. And then we add a third first level element, which is also going to be a short text, which we're going to call input3. If I trigger this function on click, I will create a ZUL file. You can see the ZUL output right here, which represents that data structure as a ZUL file. Now I can do many things with a ZUL file. I can, in this case, I'm just exporting it to the log, to the client log, so I can have a look at what is being displayed. I could save it into an actual ZUL file in order to modify it by hand later. And I can just also go executions, create component directly to create the relevant ZK component from that ZUL data and put them into a host element inside of my page. Remember that I mentioned earlier that we also have a composer automatically added to our data. In that composer, I do have a listener, which I can just trigger by clicking the save button, which is added by the form model itself, which lets me retrieve here the pairs of keys and value for each of the form items that I've defined. So in this case, input one has the, where's my input one? Input one here has the value foo. If my end user makes modification into the form and then click the save button, of course, I want to be able to retrieve the modified values as well. The useful part of applying this method is that I have decoupled the form data structure and the ZK component that create that form. So let's say that my input two, instead of being an integer, has now to become a short text. We change the shape of the model, and we're going to call this one foobar, for example. When I reload and build the data from model, instead of creating another number input, which doesn't accept text. Now I'm creating a text box which accepts text. All right, let's go a little further with that. And let's talk about creating that model automatically. What would be a good way to describe the shape of a form? JSON is a structured data format where we can easily parse a JSON input into a form model with this approach. And then we can do something with that form model, which is creating ZK components, creating ZUL file, etc., etc. The model itself, being a Java object, can be filled by any parser. So I'm going to show you an example using JSON, but you can imagine an example using any type of data input. As long as you have data that describes a form or a data structure which can be represented as a form, you can write an adapter between that data and the form model. And after that, since you've created a form model with the shape of the data, you can generate the components accordingly. All right, let's take a look at a JSON example. In a JSON example, we will start with the form object described by some JSON data. So you can see I have a name, I have the user first name, I have a type, it's a short text, and I have a default value. I want those elements to be used to create the form model. How do I do that? Well, in this case, it's simple JSON. It can just be parsed directly into the data that I have. But let's say I have a JSON structure that doesn't parse one-to-one with the shape of the form model. Since I'm doing that parsing in a Java method, I can simply do a test on the different values that exist in my input data. I can slot that into my form model, generate the model, and then generate the components out of the model. All right, let's see how that looks. If we go back to the client, I'm going to go to my second sample, which is JSON to ZUL. I've included a short description of what the expected shape of my JSON data is, which is to say a very simple name type value and then some children's which have name type value themselves recursively. And you can see here the entire form definition that I'm going to use. I'm going to open it bigger so we can see all of them. We want a first name, a last name, a password, which is going to be hidden text. We want the user to repeat a password. And then we want a label only, which will contain a subcategory of requested fields, the children here, which are going to be the user address, the user age, and some user notes. All right, when I click this button, I'm going to have that JSON parsed and create that form based on the shape of that data. The useful, interesting and useful part of doing it with JSON from a JSON input in this case, but that input doesn't have to be a text. It can be an API query. It can be a record that you get from a different process. It can be a database entry that you load, anything that provide you data that is parsable. Let's say I decide to just add a field. I do not need to go into my generated form to make some changes here. I can just go to my schema, say that in addition to the user age here, I would like to add, let's say, a user nickname. So I'm going to go into my definitions. I'm going to add a new field, which I'm going to call nickname. A nickname is not an integer, but a short text would be good. And I'll say I don't want to have a default value. So I'm just going to pass it an empty string. I'm going to recreate my form from the model. And here we go. I got my new field already set. And if I look at my at my output here, somewhere in there, I will find my nickname field, which has been added as well in the ZUL output. So again, the idea is to generate the ZUL file easily, or to just generate the component if you want to use the component directly. And once again, we want the user to be able to fill that form easily, and then to just send that data to be processed by any data processor that you might want to use it with. Click on save, and then the composer will retrieve the different values, the address, the password, etc., that I've put inside of that data shape. And you're not limited to, again, to just that ZUL. You can always go in manually once you have saved it as a file and then make modifications. Lastly, what else would be interesting to talk about? Yes, how do we go from the abstract data, which is the form model, to the JSON, not the JSON, the ZUL text? When we use the template approach, in this case, for the simple templates, we simply create a string of text that represent the ZUL output for the relevant form object. So if I want a hidden text, remember, is a password field. What is it in terms of a form? It is a label which contains the name of that item, and it is a text box that retrieves a value, but that is of type password in order to be hidden. Then very simply in this case, we create, as we would in a ZUL file, a label with the value of the node name, and a text box of type password with the node value if it has a default value, and with an ID, which is also the node name, so that we can, at the end, when the user submit the form, retrieve a node by its name. All right. Let's go to the last sample. You'll note that this form looks a little bit better than the previous one, but it's still kind of messy, kind of not aligned. We're generating ZUL content. So when we generate that ZUL content, we can simply add a style that would be usable by a ZUL page into either our ZUL output or into the page that is going to display our ZUL output. For the last example, just to make things a little bit nicer, I've arranged the labels to have the same sizes for things to be a little more aligned. And we're going to talk about the last use case that will be of interest for today, which is parsing the JSON input into just ZK components directly. Let's go to this composer. Instead of the previous composer where we created templates and then passed the node data to those templates, for creating Java ZK components directly, we will use the renderer. The renderer, as I mentioned earlier, if you're familiar with the renderer pattern in ZK, takes a node and extract data from that node, such as the type, the name, the value, and create ZK component dynamically, which essentially render the UI. This is the same logic that you would have in a list item renderer, in a combo box renderer, etc. All of those, all of those renderer-based components. All right. In this case, we will also read the JSON directly with the same logic. But instead of using execution creates component directly, we're going to simply parse the model to ZUL components directly, which gives us ZK components that are immediately usable inside of the page. There is a small trick here that is good to know, which is how to create a composer dynamically in Java code, because normally you would use a composer by just putting it in the ZUL file. When you create the components dynamically in Java code, you simply create a new composer and you call after compose on the root element of that page supported by the composer. So in this case, my form root, if you look at the ZUL generated by my previous page, in the ZUL generated, my form root is here. It's the vLayout with the S-class form. It has that apply with the form composer. Doing this in Java, form composer, new form composer, do after compose on the form root is the Java equivalent, where we're going to create the composer and assign it to that component. All right. How does this look like? It looks like mostly the same as the previous sample, because we still take the same JSON formatted content as input. We still have the ability to modify the numbers, the content of those values in the JSON, and the form generated by that shape of data will be based on that content. And now that it is a little bit more formatted with CSS, it's a little nicer to look at. And I would say formatting is not the main concern. This would be more something that you do in the presentation layer. But if you're going to use those components in the same page directly as a preview, it's nice to have them look nice enough that if you're providing an editor to an user to create the schema, it doesn't look too bad. Okay, I went quite fast because the basic concept, I think, are fairly straightforward. Let's get to talk about it. The samples are available on GitHub. You will be able to download the video of this training as well as the PowerPoint slides with this link, or you can go to this repository directly. Let me just copy it into the chat if you want to go there right now. And there we go. And let's talk about it. Time for a little bit of Q&A. My first question actually is not going to be from you, but to you. Do you think this type of structure would be an interesting fit in whichever project that you're working on? Is there a use case? Because that's something that has been reported to us by a few people, and I'd like to get an idea of how wide of a need that would be. So can I have a quick a raise of hand or a me in chat if you think that's a type of control that would have an interest for you? And while this is ongoing, let me know what you think. Do you have any question? Do you have anything you'd like me to clarify on how this would be used, how the data structure is created, how it's been transformed into ZUL or into components at the end? Let me know if there's anything you'd like me to go into further details. A grid is a good choice for a linear set of objects. I went on this proof of concept with the assumption that objects would be set in a hierarchy where you would be able to create groups of items, essentially. But yeah, using a grid, especially grid with templates, I think is a great choice. Doing something similar, but a set of base ZUL component. I see. So instead of separating it by form functionality, you separate it by ZK component, like a text box and inbox, etc., etc. That makes sense too. My thought process on this one was you may want to define a form functionality that is more complicated than a single component, where essentially you want to apply an entire template instead of applying a single item. Okay. But yeah, it's good to hear that there is some interest. Yes, yes. I That's the always the interesting part, going from the simple data structure to something more complicated. I would say in this case, my approach would be to have each of the functionalities, so each of the form objects, represent a data point, and then that data point to be more than just a string, could be a random object. Why we do generation for the composition rather than the base element. Can you clarify the questions? 'Cause I'm not sure if it's a comment of what you're already doing or if it's a question of how we would do composition here. Oh, it's an answer to clause. I see. But yeah, all right. Then I hope that was an interesting preview into this structure. And if you have an interest, I'll invite you to go to the GitHub project, take a look. If you want to leave us a comment, don't hesitate to reach to us by email on our info@zcos.com email address if you want to give any feedback or ask any question after we end the training for today. All right. I'm going to give another 2 minutes if there's any further questions before I end the call. And for anyone else, if you're happy with what you've seen so far, I feel free to disconnect, and I'm going to wish all of you a very good day. All right. Have a good day, everyone. I'll stay for another minute and a half if there's any further questions. And otherwise, have a good time. Is there a migration guide for porting ZK8 to ZK10, or is it a good choice to migrate before to ZK9? I don't think there is a guide specifically from 8 to 10. I would suggest migrating to 9 first, but the biggest suggestion I would say is if we go to our ZK9 to ZK10 migration guide, you will see a section called ZK linter. The ZK linter is a tools which will let you lint, which is to say validate the state of a given project by looking at the ZUL and Java classes and checking whether or not your project currently uses APIs or features that no longer exist in ZK10, because the main thing to know about migrating to ZK10 is that we have removed a number of APIs that were deprecated for quite a long time. I believe we've deprecated those APIs since at least ZK6. But if you are upgrading an older project, it is not impossible that you still use some of those APIs in your existing code. The ZK linter, instead of having to run the project, find the error, run the project, find the error, or to have to go to every page individually to find the errors manually, will let you simply run the linter on your project and will give you an output of all of the cases where you're using a deprecated API. Let me open a browser tab. I'll guide you through it. So if you go, just search for ZK10 migration, you will be able to find the new feature of ZK10 article in our small talk session. In this article, you can go to the upgrade notes section, and you will find upgrade tool ZK linter item 4.4. The ZK linter has a separate project, so you can go to this URL. I'm going to put it in the chat as well as the documentation link. And so just go to the introduction and setup. You will need to run it with Gradle-U. It's a portable Gradle runner. You will need to provide a few information, which is to say the packages that you want to scan, the ZUL file that you want to scan, etc. in app.properties. So just see the introduction in the project. And after running this, you will get hopefully no logs. And if you do get logs like this, it will tell you in which page or in which Java class you're using a deprecated feature that has been removed. So that will give you a good basis as to what amount of effort you will need to make when migrating from ZK8 to ZK10. And for the rest of the upgrade, I would say this entire page, the new feature of ZK10, is probably the first thing you're going to want to read, because it will introduce to you, especially in the upgrade notes, all of the limitations that you may encounter when migrating an older project. So Java 11, no longer supporting IE 11, all of those things will of course be depending on the state of your project and all of that, but I would say, yeah, start with this page. I think it's the best bet. Migrating from 8 to 9 is also a good idea beforehand, because there's not much difference in terms of internal structure between ZK8 and ZK9, and that will give you a good idea as to if you encounter any issue, whether it is something that was prior to ZK10 or after ZK10, because that will narrow the search significantly if it's not in ZK10. Okay. Let's see. Do we have any other question? I didn't see any more. If you find a bug in ZK10 EE, is there a GitHub page to pull requests or notifies? We use Jira, or you can simply send us a support ticket. If you have a support account, just let us know on support that you have found a bug, ideally with a reproducing case and instruction as to how to reproduce. You can just send that. If you have some insight that you want to share as well, if you think you found why the bug occurs or the source of that, I would say creating a support ticket is the best, most efficient way. If you want to create an account on our Jira, the URL for that is tracker.zcos.org. You can find it at this address. It is possible for external user to create accounts, but that's more hassle. And I would suggest, if you are a ZKEE user, to still send us a support ticket anyway, because if you send us a support ticket, we can probably give you a workaround. When it's a bug, we don't charge support time for creating workarounds or filing in tickets. And that also let us have our eyes directly on it. So we can more easily monitor when that bug ticket is processed by our devs. If there is any feedback we can give to our dev to make it easier for them to process the ticket. So either, send us the detail on the support ticket, create it in Jira, and then send us an email. Both of them are very good options. I think that's covered. All right. Then with that, I think we're done for today. To anyone who's still there, thank you for your patience with answering those questions. And I'm going to say have a good day, everyone. And thank you for attending. I hope that was interesting.